I will illustrate the fundamental principle of counting by considering an example. A menu for a meal consists of two starters, S1 and S2, three main courses, which we can call M1, M2 and M3, and two desserts, which we can call D1 and D2. How many different meals are possible? So let's lay out all the different dishes in a diagram. So we have a choice of two starters, and we have a choice of three main courses. Let's suppose that we choose starter S1. So here are the three options for a main course if we choose S1. Similarly for S2, we have another three options for the main course. So there are two ways that we can choose a starter and three ways that we can choose a main course. In all, we have 6 possibilities for a starter and a main course. That's just got by multiplying 2 by 3. Now, for each of these 6 possibilities of choosing a starter and a main course, we actually have 2 possibilities for a dessert. So if we select M1 for our main meal, we have dessert D1 or D2. Similarly for M2 and M3. There are 2 ways that we can select a dessert. So for each of these 6 ways that we can choose a starter and a main course, there are 2 ways we can choose a dessert. Altogether then we have 6 times 2 is 12 ways of choosing a meal. So 12 different meals are possible. We can also count the paths connecting starters to desserts. So here's one path. Here's the second path. This second path connects S1 to D2 through M1. Here's a third path. Here's the fourth. Here's the fifth. This is S1 M3 D1. S1 M3 D2 is a sixth path. So I've shown six paths here, and of course we have another 6 then when we consider S2. So we've just applied the fundamental principle of counting. If we have 2 ways of doing one thing, 3 ways of doing another thing, and yet 2 ways of doing yet another thing, then we have 2 times 3 times 2 ways of doing all 3 things, of selecting a meal. The fundamental principle of counting, which we can abbreviate to FPOC, says that if there are A ways of doing one thing and B ways of doing another thing, then there are A times B ways of doing both things. And of course we can extend this principle to doing more than 2 things. We could imagine doing 3 things. A ways of doing one thing, B ways of doing a second thing, and C ways of doing a third thing. Just like in the example involving the different meals. We have 2 ways of selecting a dessert, 3 ways of selecting a main course, and 2 ways for a starter, 3 ways for a main, and 2 ways for a dessert. So, by the fundamental principle of counting, there are A times B times C ways of doing all 3 things. So that's 2 times 3 times 2 equals 12, as we saw earlier. A combination lock consists of 3 discs with the numbers 0 to 9 on each disc. How many different locking codes are possible? Well, from this picture here, we see that the numbers 924 have to be displayed in order to open this lock. Well, there are 10 numbers on the first disc, the numbers 0 to 9. So we have 10 ways of having a number appear on top. 10 ways for that to happen, because there are 10 numbers 0 to 9. And for the second disc, we have another 10 ways. And for the third disc, we have yet another 10 ways to position a number on the top position here so that we can open the lock. So in total, by the fundamental principle of counting, we have 10 times 10 times 10 equals 1000 ways of choosing a 3-digit code. And of course, only one of these 1000 codes will open the lock. coin and a die are thrown, how many different outcomes are there? By an outcome, we mean what face of the coin is visible and what number appears uppermost on the die. So there are two ways that a coin's face can be visible after a coin is thrown, because there are two possibilities, heads or tails. As for a die, there are 6 possibilities for a number to appear, because on the die we have the numbers 1, 2, 3, 4, 5 and 6. So there are 2 ways for the coin to appear and 6 ways for the die to appear. So by the fundamental principle of counting, we have 2 times 6 equals 12 different outcomes for the throw of a coin and the throw of a die. So I could start to list some of them. You know, if we suppose that the coin appears with heads, then we have H1, H2, all the way to H6. If we throw tails with the coin, we could have T1, T2, all the way to T6. And as you can see, we have 6 and 6, 12 different outcomes.